Hi, I'm Charles Wilson, founder and CEO of Transelectric Corporation. Transelectric is a clean energy company that has developed and patented the HEFTEG system and method. We've created within the industry a whole new category, the mixed technology sector, or MTS. What I'd like to do is to give you an overview of our system while touching on three key points. One, how HEFTEG uses solar-powered electrolysis along with thermal recovery to generate energy, hydrogen, and oxygen without external fuel sources and little environmental impact. 2. How HEFTEG solves the intermittency issues with other platforms and the safety and regulatory concerns with nuclear power. And 3. Why the world needs the mixed technology sector. So let's start with what HEFTEG is. HEFTEG is an acronym for the Hydroelectrolysis Fueled Thermal Electricity Generation System and Method. Our patented utility scale system generates clean energy as well as hydrogen and oxygen all in one platform. HEFTEG produces its own fuel, so it's not reliant on conventional fuels and isn't grid dependent. The only byproduct produced are water and heat, so there are no toxic wastes or ancillary expenses. So how does HEFTEG work? Well, it's a very simple design. There are 5 main components: the solar array, the electrolysis pool, the thermal reaction chamber, the containment vessel, and the steam turbines. These components are grouped into 2 sections: fuel production and power generation. The fuel production section is composed of 2 parts: the solar array and the electrolysis pool. The array provides power for the electrolysis process and storable energy for nighttime operations and bad weather conditions. The electrolysis pool creates fuel for the power generation section by using hydroelectrolysis to create H2 and O2. These gases are then collected separately, and they are either sent to the thermal reaction chamber for immediate use or they're stored for later use. The pool itself has a unique design. The pool is sectioned into individual electrolysis pods. Each pod is divided into an anode and cathode chamber to keep the gases separate. Inside each of the chambers is a stack screen configuration. Each screen in the stack serves as an individual electrode, and each successive screen in the stack has a larger gauge opening than the one below, allowing bubbles to detach and pass through freely. Finally, each individual screen has dual connection points. This configuration reduces path resistance and IR drops across each mesh. With this stacked screen design, we've maximized the output of each individual pod. And here's the interesting part. The pods themselves can be stacked vertically, which maximizes available space. So now on to the power generation section. This section is composed of the thermal reaction chamber, containment vessel, and standard steam turbines. Let's start with the thermal reaction chamber. The TRC is located inside the containment vessel and is surrounded by water. This is where the H2O2 fuel undergoes thermal reaction to produce heat at twice the operating temperatures of other platforms. Next is the containment vessel. This structure serves 2 functions. First, it holds the water that absorbs the heat generated by the TRC, and second, since HEFTEG has higher operating temperatures and pressures, it safely contains superheated and superpressurized steam that is then sent to the steam turbines. Finally, we get to the turbines. The turbines themselves are just standard turbines, the same ones they use in other platforms. The difference is this: most plants use a 1-to-1 ratio, one source with one turbine. Because HEFTEG is designed to operate at higher parameters, its design can drive multiple turbines, which increases the total output of each site. Now let's talk about continuous operations. So the solar array is designed to produce more power than the pods use during the day. This surplus energy is then stored and used for nocturnal operations in inclement weather conditions. Likewise, the electrolysis pool is designed the same, to produce more gases than are used during the day. These surplus gases are again stored for nighttime operations in bad weather conditions and as a secondary marketable commodity. As you can see, HEFTEG eliminates intermittency while adding additional revenue streams. So how does HEFTEG compare to other energy platforms? Well, let's see. Nuclear. With HEFTEG, there are no radioactive fuels, no spent fuel storage, no reactor licensures, no long-term development and structural timelines, and finally, HEFTEG wouldn't need to overcome public resistance. With solar and power, we use water and sunlight to make hydrogen and oxygen, store them, and then turn them back into steam power. That fixes solar and wind intermittency issues. How about fossil fuels? With HEFTEG, there's no carbon output. HEFTEG generates its own fuel, so it's not subject to market volatility or procurement and storage expenses. Built with standard industrial technology, it's clean, steady power without nuclear risk, fossil emissions, or weather issues. So let's look at it from a business perspective. Let's keep it simple. Investors ask themselves two things. When am I going to get my money back? And how is my company going to make a profit from this? HEFTEG answers both of these. Let's look at ROI first. HEFTEG is standardized with mostly off-the-shelf hardware. This means fewer surprises and a short build operating time. I'll use Wawa as an example. It's interesting how they build their convenience stores. They use one standard store design, permitting instruction timelines mapped out. They can literally construct a single store, start to open, in 90 days. HEFTEG is modeled along those lines, from start to operations targeted at 30 months. Next, what about profitability? HEFTEG produces three marketable commodities: A, clean energy, B, clean hydrogen, and C, medical grade oxygen. This platform shows how you're going to get your money back and how you're going to make a profit. So to close, as I mentioned, HEFTEG creates the mixed technology sector. So why do we need this sector? MTS represents a transformative approach to energy, combining established methods with contemporary technologies across hydrogen production, thermal energy storage, and renewable power generation. I'd like to extend my gratitude to S&P Global for the opportunity to introduce HEFTEG to everyone. Have an excellent day, and as always, please take care.